David Tucker, and welcome to the course, Designing Machine Learning Solutions on Microsoft Azure. I am a cloud consultant, and I help organizations every day plan, build, and implement custom data solutions in the cloud. I have over 15 years of experience in software architecture and development. Now, when working on data science initiatives, it can be challenging to gain actionable insights from your data set. In this course, Designing Machine Learning Solutions on Microsoft Azure, you will learn how to leverage Azure's machine learning capabilities to greatly increase the chance of success for your data science project. First, we will review team workflow and how Microsoft's team data science process enables best practices across disciplines. Next, we will review the workflow of the Azure Machine Learning Service and how it can be leveraged on your project. After this, we will review how to create a pipeline for your data preparation, model training, and model registration. Finally, we will review the infrastructure approaches that can be leveraged for machine learning and how these approaches are supported on Azure. When you are finished with this course, you will possess the skills that will be needed to start a data science project on Azure and the tools that will increase your ability to gain those actionable insights. Hello, and welcome to the course, Designing Machine Learning Solutions on Microsoft Azure. My name is David Tucker, and I'm a technical architect and cloud consultant. And every day, I help organizations bring their data experiences to life in the cloud. Now, we're going to be looking at three key components over this course. We're first going to be looking at workflow, because without an effective workflow, team data science work cannot be successful. And then we're going to be looking at the data pipeline, understanding how we work with our data from beginning to end. Then we're going to be looking at infrastructure, how we leverage the resources provided by Azure to complete our data science initiatives. So over the course of this initial module, we're first going to be reviewing the current challenges for implementing data science best practices. Then we'll be understanding the benefits provided by the Team Data Science Process, or TDSP. Then we will review the resources that are provided as a part of the TDSP. Then we'll be creating an Azure Machine Learning Service workspace, and we will provision compute infrastructure for Azure Machine Learning. Since we're talking about workflow, it makes sense to talk about some of the challenges that exist with doing data science work in our current climate. First of all, it's important to understand that we've seen data science explode over the last 3 to 5 years. And what that means is most individuals that are coming in from different disciplines within our organization. Now, some of those include some people that are coming in with a development background. And so they're coming in with computer science experience. And so they're coming in with all the best practices around development. And then we have individuals that have been responsible within organizations for data warehousing, managing data, and then data mining, trying to pull insights out of that data. Then we have other individuals that are coming from a research and domain expertise background. So they're in our organizations trying to solve strategic business and organizational problems with data. And then we have individuals that are coming in from a pure mathematics and statistics background. Now, the challenge here is each of these disciplines come in with different best practices within each of their areas. And so let's look at just a few of those across a few disciplines. So for example, when we're talking about computer science, we're looking at best practices for things like version control, which allows us to track any project assets over time, including their changes. Then we have other best practices like continuous delivery, which enables us to automate our process for building, testing, and deploying. Then we also have a Scrum methodology, which falls under the overall Agile umbrella as one of the methodologies to implement Agile principles within a project. So you have developers coming in with processes like this. But then within data mining, we have an entirely different set of processes. And then you have standards like CRISP-DM, which is the cross-industry standard process for data mining. And it is the most widely used model when we're looking at data mining. And it was initially created in 1996. But even within this, there are modifications on this, such as ASUM-DM, which is just a modification that IBM created off of CRISP-DM. Then you also have Knowledge for Discovery in Databases, or KDD, which is another widely used data mining technique. And then on top of that, we even have other variations like SIMA, for example, that some organizations are using. And so when we have this environment where we have so many different best practices coming to bear within a single workflow, it can be difficult to make things work effectively. And we've seen that with the fact that 87% of data science projects never make it into production. Now, just as a note, this number is hotly contested by a lot of people. Depending on the research you look at, this number will change. But I think what we know for sure is that many more projects fail than succeed. So what is the goal of a workflow within a data science, specifically a machine learning project? Well, the goal here of the workflow is to increase the likelihood of producing actionable insights that can be operationalized within your organization by leveraging cross-discipline best practices. And Microsoft has put together the best practices across these disciplines into a single process called the team data science process that we're going to look at in the next clip. So in this clip, we're going to examine the team data science process. And if we define this, the team data science process, or as we'll commonly refer to it, the TDSP, this is an agile, iterative data science methodology, and it's designed to deliver predictive analytics solutions and intelligent applications efficiently. So it is a process that we can implement for an entire team working to achieve these goals. Now let's look at the 4 different components that are a part of the TDSP. First of all, we have a data science lifecycle. Now don't confuse this with a process for actually accomplishing tasks. In this case, this is an overall lifecycle of the project from inception to completion and making sure that you understand each of the phases that need to happen within that process. Then we have a standardized project structure, and this is where we're looking at pulling in some of the best practices from the computer science side. We have a standardized structure with version control that enables us to track key deliverables and insights within the project. And then we have infrastructure and resources. And this is what is provided by platforms like Azure Machine Learning, for example. And while the TDSP is not specific to Azure, there certainly are many integrations that work well with the TDSP. And then we have tools and utilities. So we have things that Microsoft has built that we can leverage within our projects that also become the foundation for common tools and utilities that we can use for multiple projects within our organization around data science. So let's first examine each of these in turn. First of all, let's look at the data science lifecycle. So within the TDSP, all projects start with business understanding. This means that you're defining your objectives. You're first trying to identify what is the question that we're trying to solve. We need to understand the business problems. And as many have pointed out before me, this is actually the most challenging part of the whole project, because unless this is done correctly, there will never be agreement on what success is. But the next piece of this that's critical is you also need to identify the data sources. So what are you going to use to try to answer the question? Then we see this transition into data acquisition and understanding. And this is where we start to look at a lot of things around our data, the pipeline, the environment, and how we're starting to wrangle that data and clean it so we can use it. So really we're looking at ingesting the data first of all, and then exploring the data, which will include several different steps. We then can transition out of this across to modeling. And one of the things you'll start to notice here within the life cycle is, in many cases, we're going to be traveling back and forth between these phases. It's iterative. It's not a once and done life cycle. So here within modeling, we're really looking at doing both, feature engineering, model training, and then ultimately model evaluation to see if this is actually suitable to use within your organization for your use case. Once we have this in place, we're then looking at deployment. And deployment might be a bit of a misnomer here. It's more than just actually deploying this to a solution so it can be leveraged. It's how we actually operationalize the learnings that we've gained through our model. And then ultimately, once we've iterated on this to where we're at a point where we have a high level of confidence that we have answered our business problem that we started with, we then transition into customer acceptance. And this then becomes the end of the life cycle. So this is the data science life cycle, and we will dive into this in more depth in the next clip. But then we have a standardized project structure. And first of all, the TDSP template is available in GitHub. It is open source. Anyone can leverage it for any platform. And this enables the storage of all project assets for each phase within the repository. And it includes templates for standard project deliverables, things that are critical like your project charter, as well as some of your data reports, model reports, and your model performance metrics. And so we'll also be reviewing in a future clip more of this project structure, and we will even demonstrate how you can clone this for your own data science initiative. Infrastructure is very critical here because this does enable reproducible analysis. And this is what avoids duplication, which can lead to inconsistencies and unnecessary infrastructure costs. So these tools are provided to provision the shared resources, track them, and allow each team member to connect to these resources securely. And so this is why building our TDSP project around a platform like Azure Machine Learning enables us to take advantage of the infrastructure that is provided by the platform. Now, the last component has to do with tools and utilities. So first of all, these are also available within GitHub. And we have first the Interactive Data Exploratory Analysis and Reporting Tool, or IDEAR. And in this case, we're looking at support for this, including R, Microsoft R Server, as well as Python. And in addition to this, we also have the Automated Modeling and Reporting in R tool, which as it says, is available in R. So these are the 4 different components of the team data science process that we can leverage within our data science initiatives. So now that we've defined the TDSP, or team data science process, we're now going to look at the first key component of that process, which is the data science lifecycle. Now, as a review, this means we start off with our business understanding. This is always the first part of the lifecycle. That's then followed by data acquisition and understanding. And this is where we look at our data source and pipeline, all of the information around how we get our data and how we prepare it. Then we have our modeling phase, which includes feature engineering and model training and evaluation, ultimately leading to our ability to deploy and operationalize what we're doing within the insights that we've gained. And ultimately, this will then lead to customer acceptance, which will be the end of our project. So let's break each of these areas down in part. But first of all, let's look at the team roles that are associated with the TDSP, because this will factor into the life cycle. First of all, we have the project lead, and this is going to be the individual that ultimately is responsible for what the team is going to produce. And then we have the data scientist, and this is the individual who is going to be responsible for analyzing and pulling actionable insights out of the data. We have the project manager, which is going to be the individual that helps manage the day-to-day process of the team. And then we have the solutions architect, and this is going to be the individual that is responsible for ultimately how this insight is going to be operationalized within the organization. Now let's look first at the business understanding phase. So first of all, within the business understanding phase, we're going to need to create the initial template repository. And this is usually based off of the TDSP template that is within GitHub. Because what we gain in there is we gain the templates that are needed to document key deliverables within our overall project. And so, for example, one of those deliverables is the project charter. So out of that repository, you can then create the project charter. And within the project charter, we're going to be able to answer key questions for the project. For example, we're going to define what is the core business problem that we're looking to solve and what question are we trying to answer. Now, Microsoft details within the documentation for the TDSP 5 different kinds of questions that we can ask for a data science initiative, which includes how much or how many, which is a regression problem, which category, which is a classification problem, which group, which is a clustering problem, is this weird, which is anomaly detection, and then which option should be taken, which is a recommendation problem. So we need to define this within this phase and ultimately lead to a project charter. So within these diagrams that I'm going to be showing, anything here that is green is a deliverable of the project. And so within this initial phase, we want to be sure that we have all of these tasks completed. And then we transition into the data ingest and understanding phase. And when we look at this, we're really looking to ingest the data, explore it, and ultimately set up a pipeline so that we can regularly get in new data. So first, we're provisioning any needed data infrastructure. We're then looking to provision compute assets, and these are the assets that we will use as a part of our deep learning activities. And then we'll be looking to actually bring in our data and start to explore it, with that ultimately leading to a data summary report. And there are tools that are provided that we'll talk about in upcoming clips that Microsoft has provided to make this report creation easier. But then for the solutions architect, we're going to be looking at designing that architecture to make sure that that is in place, and then ultimately having a diagram that can be included within our project documentation. And so this is the data ingest and understanding phase. Once we get through this, we're ready to really get to the meat of what we're looking to do, which is the modeling work. And so first, we're going to be developing a data pipeline. And this is what is going to enable us to get the data in the right place so we can start doing feature engineering and model training. And then from here, we will transition into those steps that I mentioned of feature engineering by the data scientist, ultimately model development, and then coming from there, ultimately a model report that is going to detail what we learned through the modeling process. So next is deployment, and this is where we're looking to operationalize the model. And this is where we deploy the model and the overall data pipeline into production so that we can actually leverage it for the insights that it's going to provide. So we'll start off with developing a scoring process, and then we'll look to deploy our data pipeline out into production. We'll see all of those things feed into actually monitoring the health and metrics of what we're creating overall, making sure that we have efficient ways to monitor our data pipeline and then however we're deploying our insights, which could be, for example, a dashboard. But it also could just as easily be something like an API that we're exposing so we can use these insights within custom applications. And once we get to this part, and again, we're going to continually iterate, so we could deploy many, many times before we reach the end of the project. But once we get to a point where we feel as though we have accomplished the goals that are defined within the project charter, then we'll transition into acceptance. And the first step for acceptance is that data scientist is going to be checking in the final artifacts of the project. Now that's going to lead to several things that'll happen simultaneously. We'll first decommission the compute assets because they won't be needed anymore because we won't be in active development. And then we're also going to checkpoint the project at whatever point that we're at. And then we'll look to actually transition into more of a production support role as opposed to an active development role for this model. And then we'll be finalizing our documentation, and that will lead to a final project report for all the work that has been done. And again, this will be in alignment with the project charter that was created initially. And so when we talked initially about the goal that we have for workflow within a machine learning project is that we're going to increase the likelihood of success. That ultimately is the goal. And by utilizing the TDSP and defining many of these challenges at the beginning of the project through that project charter, we're going to be able to get to customer acceptance faster than if we simply tried to discover those things along the way. And so you can utilize the templates and the tools that are provided by Microsoft to implement the TDSP in your project. So now that we have a good understanding of the data science lifecycle within the TDSP, next we're going to be looking at the resources that are provided as a part of the TDSP. Specifically, we're going to be looking at two different things. So first of all, within this demo, we're going to be looking at the TDSP project template that we have that is going to be in GitHub. And then we're going to be looking at the TDSP tools and utilities that also are found in GitHub. So let's dive in and take a look at both of these. So first of all, within the exercise files that are a part of this module, you will find links to both of the GitHub repositories as well as the TDSP documentation so that you can go explore these on your own. But here within the project template for TDSP, we want to call out a couple of key things. First of all, there are 3 core directories that we'll find within the project structure. The first is a code directory. And from within code, you'll notice here that we have 3 different folders corresponding to 3 out of our 5 different phases within the TDSP, including data acquisition and understanding, deployment, and modeling. And within each of these, we'll see information including things like what a data prep file would look like and how your data pipeline JSON definition would be included within the project. These are simply placeholders for what you would put in from your project. Now, if we navigate back to the root of the project, we're going to now transition over to the docs folder. And within here, this is where we gain several samples that we can include for our reports that are deliverables of our data science initiative. So for example, we can go in under the project level, and we can see here that we have a sample charter file. And this charter file is going to be able to walk us through the answers that we need to be able to provide before we actually jump in and start work on our initiative. And this includes things around business background, the scope, laying out your team, what are the metrics you're trying to identify, being sure you're planning key milestones, you're detailing your architecture, and you're covering how you're going to communicate with stakeholders for the project. So these are all essential items that should be completed in the initial business understanding phase. And so the TDSP template will walk you through the process of creating that within a markdown file that will be included within version control for your specific project. And there are other samples that are included here as well. We have an example exit report, which is going to clearly give us information that we need to include in terms of finishing out our project, as well as a place for us to drop in our system architecture for how we're going to be implementing things. Now, within the last folder, we have sample data. Now, it also notes here that this is not for storing the data for your entire project. As a matter of fact, you should keep this data to a minimum. It clearly says here in the README file that this is not for entire data sets, but what this does is it includes samples that you can put within your repository. And so you have both processed and raw data that would be included within here, and then you could use that to run tests before you actually deploy that on a large scale against your entire data set. So we would want to have some small samples of our data included within here. So this is the TDSP project template that is included within GitHub. In the next clip, we'll be cloning this repository with Git to start a new project. But let's transition over to look at the utilities that are also provided as a part of the TDSP. So here, within the Azure TDSP Utilities repository, we're going to have the utilities that we mentioned in the previous clip. We're going to have the IDEA tool in R, Microsoft R Server, as well as Python, and the automated modeling and reporting in R tool. And so these are all included, and if we click on any of these, we're going to gain insight into how to actually run these utilities within our project. And so we can see here, for example, that we can run IDEA within Jupyter Notebooks utilizing Python 2.7 or 3.5, and then it walks you through the process of actually generating a report utilizing IDEA for within your TDSP projects. Now, we'll be walking through this process as well within a future module. But these are the two different repositories that you will be leveraging if you're implementing the TDSP process within your project. Now, this TDSP Utilities repository is designed to be cloned, and then you can use this to store utilities that you can share across multiple data science projects within your organization. So now that we've reviewed the team data science process, we're going to actually create a project and interact with Azure Machine Learning Services within this demo. So first, we're going to be creating an Azure Machine Learning workspace that we'll be leveraging. Then we'll clone the TDSP project template. We'll configure VS Code to work with Azure Machine Learning. We'll provision compute resources in Azure Machine Learning from the Python SDK, and then we'll decommission those same resources. So let's dive in. So I'm here in the Azure portal. Now I'm going to navigate to the Machine Learning Service. And then from here within the Machine Learning Service, I just need to click Add. So I'm going to create a new machine learning workspace. We'll give this a name. We'll be sure that we have selected the proper subscription and resource group. And then we're just going to select the basic edition, which will be enough for what we're leveraging within this demo. Then we'll hit Review and Create. And it lets us know that our deployment is underway. Now I need to open up the Anaconda prompt for my machine. Now the first step here is I want to list the environments that I have on this machine. And so I have two environments, the base environment, which is currently activated, and the AML, or Azure Machine Learning Workspace. So that is one that I've previously created, so I'm going to go ahead and change into that environment. Now that we're in this environment, we're going to use pip to install the Azure Machine Learning SDK that we'll be leveraging in this demo. Now that we have that installed, I'm going to navigate into the Documents directory. And then from within here, we need to now clone the TDSP project template for our project. And we're going to clone it into a directory that we'll call AZML project. So here we're going to call git clone, and we're going to pass in the HTTPS clone URL for the project template, and then we're going to put in the directory that we want to put it in, which is azml-project. Now that this is done, we're going to change into that directory. And then we're going to open it in VS Code. You'll notice here in the Explorer, we have all of the same directories that we looked at when we reviewed the GitHub repository, because we've cloned this for our project template. Now the first step we need to take is actually navigating to the Extensions tab, and we need to search for Azure Machine Learning. We're going to find the extension, and we'll install the extension. Perfect. Now we have this extension installed within our VS Code instance. Now let's navigate to the Azure tab. And we'll notice here that it does want us to sign in. So I'm going to go ahead and click the Sign In button. So now I've selected my account and it's letting me know that I've signed in. So now I'm going to navigate back over to VS Code. So here you can see I have a subscription named Pluralsight. And if I go in and look, I have my PSML workspace that we created within the portal. And I also want to call out here for compute resources, we only currently have local compute set up. And this is what we're going to provision. Because in many cases, within your TDSP project, you're going to need to provision compute resources, and then once you get to the end of the project, decommission those resources. And so we're going to include the logic to do that within our TDSP template so that this could theoretically be executed by any member of our team. So let's navigate back over to the Explorer. So within the Data Acquisition and Understanding directory, we're going to create a new file. And here within this file, I'm going to paste in the implementation. So the first thing that we need to do within this file is we need to be sure that the Python interpreter that we're selecting is the correct one. So we need to now select the Python interpreter for our AML environment. Now that we have that selected, we'll notice that the errors go away, and we'll notice that we're pulling in the modules that we need from the Azure Machine Learning Python SDK. We're then getting a reference to the workspace, we're then giving a new cluster name, and then we're going to go through and attempt to create this cluster if it doesn't already exist. So we're now going to go in and run this file. And it's brought us over to do interactive authentication. We can now navigate back over to VS Code, and it tells us that the interactive authentication successfully completed and that it is now creating our compute resources. And now it lets us know that it has succeeded in creating those resources. So if we navigate over now into our Azure tab and we go to Compute and we hit Refresh, we're going to see that we now have a TDSP cluster. And if I right-click and go to View Compute Properties, and you'll notice here that we are using the standard NC6 VM types, and these have GPU support, in this case with one NVIDIA Tesla K80 GPU. We also here have our scale setting set, so we have this set from 0 to 4 depending on what we need, but our current node count is 0. So theoretically it hasn't created any of these yet, but we do have the cluster for our compute to be able to fire up those instances as needed. I'm going to close out the properties file, and we're going to add in another file into our project, which is going to be decommission. So here within this file, we're basically going to do the opposite of what we did with the provisioning. We're going to get a reference to the workspace, and we have our cluster name, but then we're going to go through and we're going to delete it as long as it exists. So we're going to go ahead and run this file. And now it lets us know that our cluster is deleting. So if we navigate back over to the Azure tab and we refresh, we'll see that the TDSP cluster currently has a different state. And if we go in and we look at the compute properties, we can see here that the provisioning state is deleting. So in this case, we have been able to both provision and decommission our compute infrastructure that we would need for our project. And we've included these files within the TDSP project, as this enables any member of the team to be able to execute these commands. So we've discovered a great deal in terms of the workflow aspect of designing and architecting a machine learning solution on Azure. In this case, we've been focused on the team data science process and how that integrates in with Azure Machine Learning. So let's take a look at what we have been able to cover over this module. First of all, we have reviewed the current challenges for implementing data science best practices. This is an important step of understanding workflow, because we talked about the goal that we have is with our workflow, we are trying to increase the chance of success of our data science projects. Then we understood the benefits that are provided by the team data science process. We looked at how the TDSP brings best practices across multiple disciplines together to form a common workflow that everybody can leverage. Then we reviewed the resources provided as a part of the TDSP, which includes both the project template as well as tools and utilities, and we talked about what languages those tools and utilities are supported in. And then we created an Azure Machine Learning Service workspace, and this is what we'll be leveraging as we move on into the next module. And then we provisioned compute infrastructure for Azure Machine Learning, which is a step within the TDSP.